The given function fx is defined when each of the two terms are defined. The first term is defined for all x except when the denominator is 0. So 4 minus x squared should not be equal to 0, or x should not be equal to either plus 2 or minus 2. So let's call this condition 1. Moving on to the second term, the log of a number is defined when that number is strictly greater than 0. Therefore, x cubed minus x should be strictly greater than 0. Factorizing the left-hand side, x times x squared minus 1, which is equal to x times x minus 1 times x plus 1, should be strictly greater than 0. Now this is possible either when all three of x, x minus 1 and x plus 1 are greater than 0, or when two of these numbers are negative and the third one is positive. So writing down all of these scenarios, either x should be greater than 0 and x minus 1 should be greater than 0, or x greater than 1 and x greater than minus 1. All of these conditions are satisfied when x is greater than 1. The second possibility is that x is greater than 0, but the other two numbers are negative, so x is less than 1 and x is less than minus 1. Now x cannot be greater than 0 and less than minus 1 at the same time, and therefore this scenario is ruled out. The third scenario is that x is negative, but x minus 1 is positive, so x is greater than 1, and the third number is negative, so x is less than minus 1. Again, x cannot be greater than 1 and less than minus 1 at the same time, so this scenario also produces no solution. The next scenario is that x is negative, x minus 1 is also negative, so x is less than 1, and the third number is positive, so x is greater than minus 1. All of these conditions are satisfied when x is greater than minus 1 and less than 0. So the two conditions that emerge for the second term in fx to be defined are either x is greater than 1 or x lies in the open interval minus 1 to 0. Let's call this condition 2. Now combining 1 and 2, the domain of definition of fx is x not equal to plus minus 2 and either x is greater than 1 or x lies in the open interval minus 1 to 0. Now laying this out on the number line, the relevant points are minus 2, minus 1, 0, 1, 2, 3, 4, and so on. First condition implies that x should not be equal to minus 2 or 2. The second condition implies that either x is greater than 1 or x lies in the open interval minus 1 to 0. And therefore, the domain of definition of fx is either when x lies between minus 1 to 0 or when x is greater than 1 but excluding the point 2, so the open interval 1 to 2 and the open interval going from 2 onwards to infinity, which is the required result.